Hi, very good day for everybody. Okay, for today we are going to do presentation on the interactive simulator for microprocessor learning. Okay, so for the abstract, this innovation is introduced to have an interactive web-based simulator to support a student learning in the microprocessor fundamental, because we had a survey and we found out the students have struggled to understand the basic instructions in the microprocessor, especially in the conditional flags and also operations such as arithmetic, logical, and also conditional flags. So the step-by-step with the real-time flags updates are included in this innovation in the microprocessor simulator. Okay. And next, introduction. Okay, as we found, the traditional teaching method is like lectures notes, textbooks notes, all this like is not fully enough to express the complex topics. So that to overcome this challenge, we introduced to the microprocessor simulator. Okay, so the goal is to have a more engaging and hands-on learning experience to the students. Okay, next, the objective to help students have a better understanding on how microprocessor instruction works, okay, with the step-by-step simulator, and also to increase students' confidence in solving microprocessor problem, and also to have a learning tool that interactive visually and also easy to use without any installation. Okay, flowchart of the innovation idea, basically it start using ADDIE model, which is start with analysis. Okay, we analyze the student difficulty and understand the microprocessor topics and teaching methods. Okay, then we design for the feature for the simulator and what are the topics that we are going to cover on that with the interactive layout, and then we develop the web-based simulator for the interactive elements, and then we do the implementation activities for the microprocessor course, and the guidance given to the lecturers who teaching the subjects, the courseworks, and also to the students as well. Okay, the evaluation on the feedbacks from the students, all around 80 students was taken, and also analyze the data using the SPSS version 23.0, and some review and also recommendations for future improvements was get from the students. Okay, so this
For
is the
microP simulator, okay, we have few aspects, which is simulator, notes, graphics, videos, and practice. Okay, first we go for simulator. So this simulator will be helping the students to understand better about the operation types, especially arithmetic, logical, and also shift and rotate. Okay, for the first one, okay, for the under the operation type of arithmetic, student can learn about the addition, okay, with add with carry, subtraction, multiplication, and also divisions. So students can choose which one they want to do. Okay, for example, additions. So this simulator can support up to 32 bits. So for example, if student want to add the number 0 times 22446688 and 0 times 77553311, okay, they can choose the number format, whether they want in the hexadecimal the answer, or in binary, or in octal. So for this case I put in the hexadecimal, and then they can choose also whether the answer in the binary they want to show or they want to hide it. Okay, and they also can choose whether they want to see the flowchart or not. Okay, then they can press the calculate, and they press the calculate. Here will be step-by-step explanations. Okay, so the final value will be shown here, and also the flag will be updated. Okay, so they can press play and they can see the steps. So if they want to pause it, they also can pause it, or they want to go front, also they can go front and see the explanations will be explained, and they will explain also why the flag overflow is occurred. Okay, student can see from here. Okay, for the then it goes for the sub also, they can do, for example, for the subs, okay, 0 times 800 0, okay, 56, Okay, the input B, they can put like decimal number 136 for example. Okay, and then they can click calculate. Okay, then if it shows overflow is activated, okay, then they can see the step by step from here, explanation from here for this one also. Okay, so it goes for others also. Okay, next is a logical. Okay, logical we have and with flag, or exclusive, or bit clear, and move not with set flag. Okay, so for example, if they want to do some or, so they can just key in 0 times f f f f f f f f f f f 0 times 1 2 3 4 3 5 1. Okay, and then they can calculate, and they can see the explanation as well, how the data was moved in a OR operation. Okay, and also what are the flags that updated here. Okay, so next they can go for shift. Okay, shift we have logical shift left with flags, logical shift right, arithmetic shift right, and rotate shift right with flags. Okay, so for example, they can choose whatever numbers they want. So they can, let's say they choose 5 5 4. Okay, they want to shift one bit for the left logical, then they can press calculate, and the students can see here how it's shifted. Okay, shifted by one position, then no flags are occurred in this question. Okay, so it will be updated too. Okay, and also student can rearrange if they want to 3 bits, then they can calculate, and the explanation will be shown. Okay, okay, so this is for simulator part. Okay, next for the notes. Okay, students can see the assembly language terminology from the notes tab. Okay, so basically the RT, RN, what are the definitions will be explained in the terminology, and some format examples also given. And then we have the notes for arithmetics. Okay, how the arithmetics for the add with carry, subtract, all was done. So students can see from here also the notes. Okay, so this one they no need to do any installations, it's just a web page, so they just can using this link they can browsing in their phones as well whenever they are, and whenever or wherever they are. Okay, next logical operations. For the logical operation notes also here, and sum and operations, so and 0 0 will become as a 0, so the notes are given here. Okay, and next for the shift and rotate also we have some notes here. Okay, so if shift left, 0 enters from the right. Okay, so all the notes can see from here. Okay, so reverse data type also given, and then they can go for flags. Okay, so 0 flag, what happened, what is the instruction will be returned to 0. Okay, and flag change by operation. Okay, so this is like for the simplified notes for them to know the algorithms, what happened to the conditional flags. Okay, and then we go for the graphics. Okay, graphic is a visual diagram represent the microprocessor concept. Okay, so for the processor flag we have carry flag, overflow flag, 0 and negative flag, so student can see the visual from here. Okay, and then arithmetic operations. Okay, this is for the visualization also. And then we have a architecture, so the main architecture for the basic microprocessor architecture. And then also we have a video. Okay, for the video we have a 3 also for arithmetic, logical, and shift and rotate. Okay, for the arithmetic we have the basic add, sub, mul, and division. Okay, student can choose whatever they want to see, those they can play. Okay, if they want to pause they can pause. Okay, if they want to play they can. Okay, okay, once done they can see the videos on how these operations happen. Okay, and also they can go for the logical. Okay, for the logical they can choose which one they want. Okay, let's say they choose AND. Okay, so they can see how the operation of AND are happen. And also for the shift, they can choose which one they want to do. Okay, so this one rotate right. Okay, so you can see how is that happen. Okay, rotate by 2 bits. Okay, so the notes are given also and with the explanation. And then students can choose an operation category from arithmetic, logical or shift rotate. They can try to do some interactive activities like quizzes from this web also. Okay, so for example logical, okay, what will be result for n between these two numbers. So for example if they're not sure, they can show hint. Okay, they can click hint button here, so they can get the hint, and then they can choose the answer. For example, the answer is like, so it will shown 0. The correct answer will be shown here and incorrect, and it will be explanation why it's incorrect also. Okay, so that's all for the microP simulator.
Okay, as a conclusion, we can know that this one is a very interactive learning that can give a self-paced practice to the students and also build the confidence among the students. Okay, and students can no need to depend on the notes in their textbooks or in the lecturer notes as only. They can just can use it wherever they are, and this can have a great potential to improve the teaching and learning in technical educations, to give a more illustration and visuals to the students to understand in terms of like what actually happens inside the microprocessor. Okay, so this is the reference that we get from to improving the tools. Okay, thank you so much.